Now then, cloud gurus, we've talked about the API server. Well, we're switching gears a bit now and talking about the API itself. And if I could pick one thing that newbies to Kubernetes struggle with, I'd probably say this, the API. I mean, it's massive, but it's pretty complex as well. And definitely when you're new to it, it can be less than intuitive. So prepare to be a bit frustrated and maybe feeling a bit lost at first. But don't stress over it too much. You'll get to grips with it eventually. Okay, so the Kubernetes API is where everything in Kubernetes is defined. Make sure that registers. Everything we'll be working with throughout the course is gonna be a resource that's defined in the API. Pods, deployments, you name it, they're all resources in the API. Anyway, it is a RESTful API that uses standard HTTP methods or verbs to perform CRUD-style operations. Generally speaking, right, it supports these 6 verbs and they work the same across all resources. Now we'll see as we go on with the course that these map to operations that you'll perform with kubectl, like creating, watching and deleting objects. Speaking of which, for the most part, our interaction with the API is going to be through the kubectl command line utility. So it works a bit like this. We'll define the different parts of our apps in YAML files, and we'll use kubectl to post them to the API server. Assuming we can authenticate and the likes, because RBAC is a thing these days, but assuming we can authenticate, that'll create a record of intent on the cluster in the store, yeah? That record of intent changes the overall desired state of the cluster, which in turn causes the other bits of the control plane to kick into action. Now, before we get into API versioning and the likes, I want to explain this notion of a declarative configuration. You see, the Kubernetes way of deploying and managing apps is to define the various parts of those apps in YAML files. You post these to the API server as a record of intent, and this updates the overall desired state of the cluster. Now in the background, the control plane's running a ton of watch loops that are constantly checking that the current observed state of the cluster matches the current desired state. Well, posting a new YAML file, that changes the desired state. So before long, the watch loops will notice and various parts of the control plane kick into life to bring that observed state into line with the new desired state. I don't know, an example might be a cluster with, let's say, 5 running replicas of a service that compresses images. If you post an updated YAML file to the cluster, changing the desired state to be 10 replicas instead of 5, well, the current observed state is going to be out of sync with this new desired state. Watch loops will notice and controllers will kick in to reconcile. And it's a beautiful thing. I mean, those YAML files are your source of truth, and they serve as, get this, living application documentation. Sounds cheesy, right? But it is the absolute business. We all want decent documentation, and this type of declarative model, it gives it to us for free. I love it. You basically define your app in YAML files that are great documentation. Then you give those to the cluster, and it deploys your apps. Net, your documentation is always up to date. Hallelujah. Now, I mean, sure, you can imperatively configure your apps with loads of kubectl commands and maybe some scripts. But I mean, who the heck wants to do that? That's the old way. The cloud native way and the Kubernetes way is declaratively with YAML files. Anyway, the API itself, it used to be a monolith. So all resources were defined in, I guess, what we now call the old core API group. But monoliths are bad, right? And as Kubernetes grew, it was a nightmare trying to develop loads of individual resources under an umbrella of a single monolithic API. So they broke it apart. And you'll see as we crack on with the course that there's now a bunch of API groups. So like all the workload stuff like deployments and replica sets and daemon sets and the likes, these are all in the apps API group. And yeah, okay, so all of the RBAC stuff, that's under the authorization group. So lots of groups, each with their own resources. And each of these API groups is kind of looked after by a special interests group, a SIG, which Rather than being lines of code in the cloud somewhere, this is actually a group of people, human beings here, that are responsible for feature development. So for example, SIG Apps, these guys own the Apps API, and they're pretty much free to do whatever they want in it at their own cadence. Anyway, resources live in API groups, yeah? And each API group is versioned. New stuff comes in at alpha, progresses through beta, and ends up at GA. The general rule is pretty much like this. Alpha features are a bit hairy, right, and they shouldn't be trusted. I mean, they're disabled by default, and you know what, they can be dropped at any point, so use with massive caution. Beta features? Yeah, definitely a step up. For the most part, they're stable-ish, and they'll probably look the same when they go GA. And then GA is just this confirmation that the feature set's stable and it's considered ready for production. And while that probably sounds simple, let me tell you, it is anything but. I mean, when you consider how big the Kubernetes API is and how fast it's growing, it is not easy to keep track of things. For your existing clusters, kubectl get API services might be helpful. But I reckon, yeah, that's the API. RESTful, CRUD-style operations, create, read, update and delete. We normally post stuff to the API server in YAML. Features are split out into their own API groups. And new features go through alpha, beta and GA. Love it. Anyway, next up we'll look at some of the major Kubernetes objects.